Hey everybody, and welcome back to another lecture with Coding with Roby. In this lecture, we will be going over JWT, which stands for JSON Web Token. JWT is one of the most popular bearer tokens and authorization protocols within APIs. So this is a good chance to get familiar with JWT. What is a JSON Web Token? Well, to start, a JSON Web Token stands for JWT. JSON Web Token is a self-contained way to securely transmit data and information between two or more parties using a JSON object. A JSON Web Token can be trusted because each JWT can be digitally signed, which in essence allows a server to know if the JSON object has been changed at all from the client. JWT is not an authentication method like BASIC and Digest, but an authorization method in which allows the client and server to maintain a relationship without having to log in each request. JWT is a great way for information to be exchanged between the server and client. Once a user logs in, the server will return a JSON Web Token, which is a string of characters that when decoded shows information about the client and user. Each time a request comes from the same client after a successful authentication, the client will send the JSON Web Token, and the server will validate the token each request. All JSON Web Tokens have similar structures. A JSON Web Token is created by three separate parts separated by dots. The JSON structure includes a header, a payload, and a signature. Therefore, a JSON Web Token being sent between the client and the server may look like the image, but instead of A's, B's, and C's, those will be unique characters for that specific client. The JWT header is the first part of a JSON Web Token that is sent between the client and server. The JWT header usually consists of two parts: the algorithm for signing and the type of token. The JWT header is then encoded using base64 to create the first part of the JSON Web Token. As we can see, the multiple A's of the image below is the first part of the JWT. This image is displaying an example of where the JWT header lies. The JWT payload is the second part of a JSON Web Token. A JWT payload consists of the actual data of the user and/or additional information. The payload's data contains claims, and there are three different types of claims. These claims include register, public, and private. Registered claims are claims that are predefined, recommended, but not mandatory. The top three registered claims include ISS, sub, and EXP. ISS stands for issuer. This claim identifies the principal that issued the JWT. Sub stands for subject and holds statements about the subject. The subject value must be scoped either locally or globally unique. Think of a subject as an ID for the JSON Web Token. EXP stands for expiration time, which is when the JWT expires. This claim makes sure that the current date and time is before the expiration date and time of the token. Expiration is not mandatory, but extremely useful. One thing you never want to do is have your token never expire. This is because if your token never expires, then anyone who has a JWT will be authorized by the server. You will always want to make sure there is some type of default expiration date attached to the JWT. I've seen different types of expiration times attached to JWTs. The one I used the most recently had an expiration time within an hour of no activity from the client. Therefore, If the user does not do anything within an hour, the JWT becomes invalid. The JWT payload is then encoded using base 64 to create the second part of the JWT. From the image below, we can see that the B's are the JWT payload and happens after the A's, which is the JWT header, and is separated by a dot. A JWT signature is the third and final part of a JSON Web Token. The JWT signature is created by using the algorithm in the header to hash out the encoded header, encoded payload, and secret. The secret can be anything, but is saved somewhere on the server that the client does not have access to. The signature is the third and final part of a JWT. From the image below, we can see that the C's are after the JWT payload and separated by a dot. This is where the signature goes. So to recap, the JWT's components include a header, payload, and signature. Let's now look at a JWT example and add all the different components together to see what we get. First, let's create the JWT header. This is a JSON object which holds alg, which is equal to HS256 algorithm, and the type of token, which is JWT. We then have the JWT payload, which has a subject of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, name, which is Eric Roby, a given name, which is Eric, a family name, which is Roby, and an email at codingwithroby@gmail.com, and the admin status is true. Lastly, we have the JWT signature, which is the encoded header, encoded payload with a secret. In this example, the secret spells out Learn Online, and all of this is hashed within the algorithm. With all of this combined, you get the JSON Web Token string. This string is completely unique to the client based on the authentication of the user that has logged in. When working with a JSON Web Token, the requester usually sends the token in the authorization header using the bearer schema. This is a different schema than the basic authentication and digest authentication that we learned before. Now, with all security measures within APIs, never send sensitive data back to the client. However, the JWT is safe as long as the client does not find out the secret key, which in this example is Learn Online. If the client was able to discover the secret key, they would have so much more control over the data. If you visit https://jwt.io, you can encode and decode your very own JSON Web Tokens. You can see I typed in the header, payload, and signature to match the example on the last slide. In return, we get the encoded JWT. If any of the information on the JWT has changed, the server will be able to identify that something was altered. For example, let's try removing a character from the secret on the encoded side. Immediately, we are shown an invalid signature. This is because I removed the last character out of the signature on the encoded side. This is why JWT is so popular when dealing with authorization. It is because of how quickly the server is able to identify data that has been altered. So what are some JWT practical use cases? Now, there are multiple different scenarios in which JWT is an amazing option for authorization. However, imagine this scenario. A single company or enterprise has multiple different applications that many different users work with. For example, let's say you want to get into cryptocurrency, and App 1 is the cryptocurrency market where you can buy and sell many different types of cryptocurrencies. Let's say the same company that owns App 1 also has another application where you can store cryptocurrencies in a digital wallet. Now, if you are the company that owns both applications, you do not want your user to have to sign into one application to buy cryptocurrencies, and then technically have to sign into a completely different application to move their cryptocurrencies into a digital wallet. It would be a much better experience if the user did not even know that there was two separate applications, and that the user experience between the two applications were not even noticeable. This is possible if App 1 and App 2 share the same secret. This means both servers would be able to handle decoding the JSON web token and know exactly who the user is that is trying to perform the action. Using JWT is extremely popular in modern architectures like microservices, where each API may be loosely coupled and in some cases completely stateless but require user information. These microservices or micro APIs can find the user by decoding tokens and never having to implement authentication or authorization within the specific API. I know this was a bunch of information, but I hope this gave you an amazing insight into how JWTs and authorization is working in the modern technology era. This wraps up this lecture on JWT, and I'll see you in the next video.